So the idea of fraction density means that between any two numbers, and I like to use a number line to think about this, and it doesn't matter what those numbers are. Let's use 0 and 1. And 1 is a fraction because I could write 1 as 1 over 1. I could write 1 as 4 over 4. So any whole number is also a fraction. Between any two fractions, there's always another fraction. And 0 and 1 can be thought of as fractions. And it gets more exciting than that, because if you pick one of the fractions in there, if you find a fraction in there, like I like going into the middle, that symmetry makes me happy. I'm halfway in between, so that's the fraction 1/2. Well, now I have another fraction, and between any two fractions, like 1/2 and 1, there's always going to be another one. Like over here, I have 3/4. So this idea that there's always another fraction between any two fractions, this actually goes on forever and turns into the fact that between any two fractions, there are infinitely many other fractions, which is kind of insane to think about. Infinity is a weird idea in the first place. Like if you count 1, 2, 3, you're eventually going to get to 100. And if you keep going, you get to 1,000 or maybe 1,000,000. There's always a bigger number when you're counting. Heading out to the right on the number line forever. Forever is a weird idea, but it turns out there's infinitely many fractions buried between any two. And it doesn't matter which two fractions you pick. Like let's draw a new number line here. And let's suppose on one side of the number line, I pick, oh, how about 1/9? And then over here, I'm going to pick 1/8. And I claim 1/8 is bigger than 1/9 because there's fewer pieces in a whole, so each piece has to be a little bit bigger. If you weren't sure about that, you could use that comparison we talked about earlier, 1/9 versus 1/8, where we do that little cross multiply thing. 8 times 1 is 8. 9 times 1 is 9. 8 is less than 9, which means 1/9 must be less than 8. Keep in mind the common denominator there would be 9 times 8, or 72. There are infinitely many fractions in between there. Let's try to find a few of them. So one way to find one is to just go for the middle. How do you find the middle of two numbers? Well, that'd just be the average. So that middle number right there would be the average. And the average of 1/9 and 1/8 would just be 1/9 plus 1/8 divided by 2. And I've actually already added them up over here without saying so. 1/9, this shows me can be written as 8/72. And 1/8 can be written as 9/72. So how much are they together? Well, I now have a common denominator. 8 plus 9 is 17 out of 72. That's their sum. And average means cut that sum in half. Let's see, how do you cut something in half? Well, you could divide by 2 or multiply by 1/2. I'm going to choose to multiply by 1/2. 1 times 17 is 17. 2 times 72, I think, is 144. And that doesn't reduce. So the number right in the middle would be 17 out of 144. Can I find other ones? Well, sure. I could find the average of 17 over 144 and 1/8, and that would give me this number right here. So I could keep finding averages and finding numbers in the middle and cut it up. So that's one way. Now I found one. What if somebody said they wanted like 9 or 10 of them in the middle? Well, then I would do something like this instead. I find a common denominator like 72. So this one right here is 8/72. This one over here is 9/72. Now, as far as whole number numerators go, there's no whole number between 8 and 9, but I could rewrite this as 80/720, and this one as 90/720. Can you think of any numbers between 80 and 90? Sure, like 81. So like right over, let's see, that's 10. So somewhere right around here would be the number 81/720. Just under 90 would be 89. So somewhere around here-ish, that number should be about 89/720. And right next to it, right around here, is going to be 88/720. So I'm going to end up finding 9 different numbers in there. Why 9, not 10? Well, starting here and counting to the end, 1/8 would be the 10th one. Right? So there's only 9 numbers in between to make a division by 10. Was there anything special about me multiplying top and bottom by 10 here and there? No, I could have picked another number and found a different number of fractions in there. And 10's kind of nice to work with. I can pretty much guess about where the numbers have to live next to each other and have an accurate ruler. So cool thing, the idea of fraction density, its basic level means between any 2 fractions, there's always another fraction. That extends forever. There's infinitely many fractions between any 2 fractions. No matter how close together you think they are, you can zoom in and find a gazillion other fractions living in there, which is just such a mind-blowing idea. All right, that's deep.